Hi everyone, this is Orit. This video is about my real online class. I teach my students how to solve two combination questions. These two questions are very similar. Both are about 6 polynomials. The sum of them is 12, from x1 to x6. Only difference is one is a non-negative, another is positive. So the solutions are different. Let's start. 3, 3, 3. Almost make sure the number on the right is always bigger or equal to the left one. Yeah. So this is in the sequence. We don't miss anything. We can find out all the combinations. Yeah, you can compare this one with what you did. Yes. See if you miss something or you got it. All of them. So 1, 2, 2, 2, 2, 3. So the last one is 2, 2, 2, 2, 2, 6, 2. Okay, good. So that's all. And we haven't finished. This is step 1. Step 2, we need to find out how many combinations for this one. So if I write 7, 1, 1, 1, 1, 1, 1, that's another solution because this is for x1. This is for x2, right? Yeah, that's different. They are different. Even all 1, 7, 1, 1, 1, 1. They are all different. Now, I just write down all the different combinations here for each of the category. For the category 1, there are 6, right? These possibilities here. For 1, 1, this one has 30. Yeah, you can calculate it in, separately for this one. Okay, I just write down all the numbers. So this is 30 again. So next 15. Okay, this is 60.
Wait, why?
Okay, which one is y? Show me. Yeah, just show me. Yeah, which one you don't know.
All of them.
So this is 100 times. Yeah, I missed something. So this one easy, right? 7 can be 6 positions. So there are 6 different combinations. So it's 7, 1, 1, 1, 1, 1, 1, 7, 1, 1, 1, 1, 1, 7, 1, 1. Okay, and 1, 1, 1, 7. Right? There are 6 positions. Do you know this one? First one. Yes? The first one. The 6, the 5 ones. 1, 6. The different combinations are 6. Do you understand this one? Yeah, if I, yeah, you know, if you don't know, don't worry. Yeah, just tell me. Tell me. You just tell me. No, I show you yeah, all the 6 different combinations here. No problem. So that's 7, 1, 1, 1, 1, 1, 7, 1, 1, 1, 1, 1, 1, 7, 1, 1, 1, 1, 1, 1, 7, 1, 1, 1, 1, 1, 1, 7, 1, and last is 1, 1, 1, 1, 1, 7. Right? From here, we can find this group or this category. There are 6 different combinations, possibilities. Do you understand this one?
No.
No? Okay. Each of them, just a solution for that. Say, I say this one. That means x1 equals 1, x2 equals 1, x3 equals 1, until x6 equals 7. This is one solution for that.
Wait, but why x6 equals to 7? How can we?
Okay, you have to plus, no problem. Yeah. 1 plus 1 plus 1 plus 1 plus 1 plus 7. What's the result? Tell me. Add them together.
12?
Yes. So, did you see that? The answer is 12. That's one of the solutions.
But why x6 is 7?
Oh, that's just one possibility. One possibility. Say, the question asks us how many solutions. This is just one of the solutions. It can be x6 can be 6. It can be 1. It can be 2. Can be 5.
But why it can be 1, can be 2, can be 5? Like,
yeah. That just means we need all the solutions. All the solutions.
Like, can the x be like decimal or something?
No, did you see that? It's an integral. Integral means this is adjective or integer. Yeah, do you see the question? It must be integer.
Yes, but
it cannot be decimal, cannot be fraction.
what's x6? What's x6?
X6 is a per numeral. Just an algebra. Do you know algebra? Any number.
No.
I don't know algebra. We can read the question.
It means x times 6?
No. X6 the 6 is the small one, the lower. This is just a one number. You can rewrite this one as, see, we can rewrite it. Oh, yeah, that's the problem from here.
Oh, it's just like XYZ something?
Yes, you can write this one with A plus B plus something plus C plus D. Yeah, good question. Oh, now I understand your computer. Yes, plus E plus F. X6 just means it's a variable, a per numeral, same as it's Y, or it's X, or it's A. This is just a denoting. Nothing fancy, okay? Yeah, you can read it as this one. A plus B plus C plus D plus E plus F equals 12. How many different solutions are there? Same. Just a name. So your name is Annie, right?
Yes.
So we just give a name. This means X6 is a name for the per numeral, right? So it can be Annie, it can be, or it's my name, or you can be Jay or something, or Jack, or William, or anyone else. This is just a name. Name of the algebra per numeral.
Okay.
You look at it as a name. It could be, we can rename it as F. We can rename it as F. Doesn't matter, right? So even if we can write down this one as the X, Y, it's a new name. But you are familiar with the say one letter name, right? X or Y. It could be two letters, right? It could be two letters. See, X, Y, or X, X. This is just one name, or X6. It's just a name, doesn't matter. Yeah, we can name it as this. Why do I do this one? Because it's easy to write. We don't need to write A, B, C, D, E, F something. Yeah, there are no patterns. But with this one, we can transfer this one into easy one. See, we can write down XI. I is from I equals from 1 to 6. That defines 6 different names or 6 different variables. Yeah, easy. Okay, you don't know the algebra. Yeah, no, it's just a name. Just look at it as a name. Yeah, that's fine. Okay, now do you understand? A, B, C, D, E, F. Yes. Okay. Yeah. So, okay. I'm on the computing. Why do you don't know this one? Okay, that's fine. Yeah, just explain to me. Yes, I can tell you. So this is just one of the variable. Or you can name it as the 6th per numeral, right? 6th per. This is first per numeral. The second per numeral. Yeah, that's it. Okay. Now this question. So 17 is similar to 18. You read? Can you read it? Yeah. In how many ways may we write the number 9 as a sum of 3 per integer? So this question 17 we can rewrite as, in how many ways may we write the number 12 as the sum of 6 positive integers? That's exactly the same as the question. We write this one as 12, this one as 6. That's the same as 17. Okay, right? Yeah. Now do you understand? Yeah, we have 6 different possibilities to the solution. Then also we can find all the others. So I can just write it down, everything. Yeah, this is 6, 30, 6, 30, 30. This is 15, this is 60, this is 120. So next is 20, this is 20. So this one is 60. This one is 40. 60, 90, sorry, 90. 90, yeah. 90, then this is 30. So this is 1, different combinations. Then we add all the, say, the blue number together. That's all the total. That's the total. Yeah, this is the total. Okay, add all that together. Yeah, we find answer. So the answer, okay, I still didn't get the answer. I forgot the answer. No, we calculate later, yes. So this is solution, the method 1, right? Solution 1. Yeah. To find each of them, same as the question 18 we did, right? Exactly same. You just list this one, 117. So there are 3 combinations. You notice 3. I saw you did that last class, right? Yeah, add everything together. Yeah, this is method 1. A little bit harder, yeah, for this one. Okay, method 2. Okay, method 2. See, we just using the circle, small balls or circles to represent the 12. So there are 12 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what do? We need to separate these 12 circles into 6 groups, right? Each group represents 1 per numeral, 1 number, right? Yeah. See, we can do like this way. See, we can here. So how many bars we need to cut them to separate them into 6 groups? How many of them? Yeah. For example, we need 1 less. So in order to find 6 different groups, we need 5 bars. You see that? We need 5 bars. 1, 2, 3, 4, 5. We need 5 bars or 5 stickers. Doesn't matter. 5 sticks to separate the 12 balls or 12 circles into 6 groups. Yeah, good. Understand. Yeah. So after the separating, we have the 1 result, 1 solution, right? So this is 1. This is 2. This is 3, 2, 1. If you add them together, of course, it's 12, right? We separate them from 12. So the answer of the sum must be 12. Do you see that? Right?
Yes.
Because the total is 12. We just separate the 12 into small parts. Now we just go backwards. Add each part together. That's 12, right? So because did you know that the total of them is 12? We have 12 circles, right? Then we separate them into small parts. Then each small part add together, the sum should be 12. Yes, right? So this is 1 to 1, say corresponding, right? Corresponding 1 to 1, yes. So if we find 1 solution, we have 1 solution for the 5 bars to separate them, right? Yeah, that's 1 to 1. Okay, now if I find another one, no worries. So if the 5 bars at different position, so maybe the first bar here, first bar here, second bar here, third bar, fourth bar, fifth bar. So that's another solution. You see that? So it's the answer should be 2 plus 1 plus 1 plus 1 plus 1 plus 1, 2, 3, 4, 5, 6. Yeah, plus 6, right? So it's another solution for sum is 12. Okay, so the first one, how can we find 1 if it's 1, 1, 1, 1, 1, 7? How can I do this one? Find this one, corresponding one, right? So if it's the answer solution is 1 plus 1 plus 1 plus 1 plus 1 plus 7, so we can still find the 5 bars to separate them. Okay, so now the answer is here, 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 and here. So this is 1 plus 1 plus 1 plus 1 plus 1 plus 7. So exactly corresponding to this one. So each solution, this is conversion. We convert this question into a game, like a game. Just 12 circles. We just find 5 bars, 5 stickers to separate them, right? So now the question becomes easier. If we find the total of the games, then we find the total of the solutions for the questions. They are exactly same, right? The total number should be exactly same. Yeah, this is 1 to 1 corresponding. Yeah. Now we do the question for the game. Okay. See how many gaps are there? So it's 1, 2, 3, keep going. 12 circles. How many gaps are there? Yeah, how many gaps? Can you see?
6. Wait.
Yeah. Circles 12.
11?
11. Yes, it's 11. See, just one less than circles, right? So we have 11 positions or gaps are there. So all the gaps we can put in a bar, right? All the gaps anywhere we can put in the bar, 5 bars. So that means from the position 11 gaps or 11 positions, we have to find out any 5 of them. I mean, choose 5 from 11. You get it? Right?
Yes.
Just randomly, anywhere. We just find any 5 positions among the 11 of that. See, anywhere, right? Anywhere, right? This is one combination. This is another combination. You already understand this meaning, right? That means choose 5 from 11. Correct?
Yes.
Yes. You already understand this one, right? Yeah, we did this before. Do you remember? Yeah, we did this before. It means choose 5 different positions. So from 11, that's all the combinations, right? So what's the result? So that's on the top. Start from 11, right? 11 times 10. There are 5 consecutive numbers. This is 9 times 8 times 7. On the bottom, just from, you can see from 5 until 1. Yeah, do you know this calculation? Right?
Yes.
Yeah, this is calculation for this one, right? Yes. Now we do the cancelling. Okay, so 5 and 2 with 10. Right, this is 10, right? Next one, 4 and 8, 2 left. Okay, 3 and 9, 3 left. So result is, so this is equal to 11 times 3 times 2 times 7, right?
Okay.
Yes, 3 times 2 is 6, 6 times 7, 42,
Oh.
42, see, 462. That's the answer. Yeah, you get it? Yeah. So this is method 2. Okay, I just write down. I don't have the answer. Okay, this is 462. Yeah, write down. Okay. See, from the conversion or transformation, we find an easy way to solve it. Yeah. The method 1 is the hardest way. It still can solve the answer. We just didn't add that together. It's the answer. I checked it. Yeah, I checked the say on the paper. It's still 462. Same as this one, right? Yes. So this is okay. Method 2. Yes, great. So I show you the easy one, right? Yes. So next time, if you see a similar question like this one or this one or the 15 different similar question for the question 17 or 18, you can use this method. Yeah, and easy to remember. Yes, to solve them. Okay, this is fast way to solve them. We don't need list everything together. Yeah, that's too hard. Yeah. Okay. Yeah. Okay. Now we can good. Yeah, you understand. Now we come to the next question 16. It looks like similar. So this is also like A plus B until plus F, right? The 6 numbers, 6 per numeral equal 12. Okay, don't worry about X6 if you don't understand it. Just a name F. Okay, this is just a name A, just a name B. Okay, right. One difference, it is non-negative, it's positive. Positive means greater or equal to 1. Non-negative is greater or equal to 0. That's the only difference. Yeah, can you think of the 16? Yeah. Everything else is same, but the solution is different as well. The method is different. Yeah, okay? Can you think over for this question, please? Okay. 16, yeah. Think for a while, yeah, I can show you. There are 3 different methods for this one, I found. Yeah, very interesting. 3 different methods. Okay, if we use the method for 18, the method 1, it's too hard, impossible almost, because the first one should be 0 plus 0 plus 0 plus 0 plus 0 plus 12. So number can be, maximum number can be 12. The minimum can be 0. It's between 12 and 0. But for 17, it's a little bit easy because the maximum should be 7. So less or equal. So the minimum should be 1. So it's from 1 to 7 for question 17. But for question 16, it's from 0 to 12. Much more combinations. Too hard yet. If we still use the method 1 to solve 16, it's almost impossible. Almost. Yeah. All right. Yes. You have to find a new way. But it's still different with 17 to use the method 2. Yeah, you can think it over for a while. Yes. Yeah, this is very interesting. We still use the idea, okay, for the similar to question 16. But this time, I use different ways, okay? Let me see what's that. Okay, done. Now I clean everything. Method 2, now interesting. All the methods very interesting, very good, yes. So it's giving us a thinking, different way to think, yeah. Okay, method 2, I also put in the bus. Doesn't matter anywhere, put in the bus. But this time, I look. Are you different color? Okay. I look. The first time, the method 1, okay. We just look these circles as elements or as items, right? This one as items or elements, doesn't matter. Items or elements. Then we do the calculation. Elements, right? Yes. But this time, I look the bars as elements or items as well. First time, we only look at the 12 circles as elements, right? But this time, all the bars also the elements. And we can mix them together to look them same. We look them same. That means if I find, say, altogether they are, say, the 12 plus 5, right? Oh, sorry, 5 stickers. I missed one of that. Yeah. Oh, yeah, 5 altogether. So altogether, how many items or elements are there? So that means 12 circles plus 5 bars, right? So there are 17 elements or items. Yeah, I try to make it slower, let you understand all the ideas. Okay. So, right, correct? Yeah, so there are 17 elements. This is just look at the sticker or chopstick, some doesn't matter anything here. This is just for balls or something here, just elements or items here. Okay, so altogether there are 17 items. Now the question is easier. That means we have, okay, I joined another color. Okay, now we have, okay, 11 positions, 17, sorry, 17 positions. How many are there? Okay, 6. Okay, done. So there are 17 positions or 17 boxes, doesn't matter. 17 boxes, right? Altogether 17 boxes. This time I just put in all the stickers, bars, and all the circles. First time I can think of put all the stickers, the 5 stickers, right? So the 5 stickers can put anywhere among the 17 boxes, right? Can put anywhere, or maybe all here, right? Also, there's 2 more. Okay, there are 5 of that, right? So rest position, rest boxes, I just put in the circles. After I choose, that means I choose 5 from the 17. I put in the stickers, each box, 1 of that. Then rest of that doesn't matter, just 1 possibilities, right? I put 1 of that. Yeah, do you see that?
Yeah.
Yeah. So the combinations we can calculate like this way. Choose 5 from 17. It doesn't matter if we put in the circles first, same way. If we put so if we don't put the bars, we put in the circles first. So that means the total is 7. Choose say the 12 from 17, right? So we put the balls first or the circle first. Doesn't matter anywhere. We put in 12 of them, right? If I put 12 of them, the rest 5 positions we can put in the bars. The same. So the rest should be only one possibility, right? Yes. So doesn't matter this one or this one. They are equal. In fact, they are equal. Do you know that?
Yeah.
They are equal. See, I show you example. See, we choose 3, or choose 1 from 3. That's equal to choose 2 from 3. Why? Because there are 3 items. See, for example, it's 1, 2, 3. If I choose one of that, this one, that means another group is 2, right? If I choose 2 of them, the another group is 1. Same. So they are same. They are equal. Also here, choose 5 from 5, 17, or choose 12 from 17. Okay, now we have the answer easily, right? So I clean everything here. Okay, I do calculation now this time. So that equals 17 times 16 times 15 times 14 times 13. On the bottom is 1 times 2 times 3 times 4 times 5. Okay, then we do canceling. Yeah, this one, this one down. 4 and 2 is 8. 16, this is 2. Right? Now we times this number together. Right? Okay, I use calculate fast way. Okay. So give me a second. Okay. Just calculate. So it becomes 17 times 2 times 14 times 13. So the answer is 6,188. If you list everything here, it's almost impossible for human, right? To list everything together is almost impossible. So it's 6,000 something, too many. So we find answer easily. Okay, this is method 2. We have method 3. And do you want to know method 3? Okay, do you understand? Yeah, do you understand method 2?
Confused.
Yeah, do you understand?
Not really.
Not really. Oh, okay. Not really. Okay, fine. That means we have 17 positions. 17 boxes here. 17 boxes. We need to find out. Okay, if you still don't understand, that's fine. I just explain it again. Don't worry. We have method 3. Yeah, maybe that one is easy for you. Method 3. Okay, you just choose any method you understand, right? Okay, so we just put in the bars. Put in 5 bars. The 5 bars can be anywhere, right? So that means we choose 5 positions, 5 boxes from 17. So if the bars are here, then the rest we can put in the circles. The rest can be circles. So this is just a one-to-one corresponding to a solution for the question x1 plus x2 plus x6 equal 12. Why? Because see, if you like this way, so the answer this one is 5. Then 5 plus, so the all total of the circles are 12, right? So this is 3, so this is 2, or this is, yes, okay. So this is the solution corresponding to this one, equal 12, right? Right? Yes, we just find convert the question into another way, another method. This new method is one-to-one corresponding to the old one. That means the old question, how many solutions? The new conversion, same solution as it is, right? We just find an equation, the equal solution So this is hard one. We just find another question solution. This is easy. But the answer of the easy one, the answer is same. The answer to the easy one and to the hard one is same. Then we can just solve the easy one. Then find the answer. As long as the easy one and hard one is equal, the question are equal, same question. Yeah, this is a way to solve the hard question. Yeah, I just give some thinking here, or the idea to do the mathematics. That's in mathematics. This is called a mathematical thinking, yeah, or mathematical thinking, right? Yeah, thinking in mathematical way. Yes, that's it. Yeah, always transfer the hard one into easy one. Yes, all right. Then solve the easy one. Yeah, that's it. Okay. Or divide and conquer. Divide the hard one into small parts. Then we solve each part. Right? Yeah, this is a method for the mathematical thinking. Yes. All right. Yeah. Okay. Now, if we find the easy one is easy, right? So easy one, just choose 5 from 17. Yeah. Okay. If we still don't understand the 5, we just talk about the method 3. Okay. We already solved. So this is the mathematical the idea. Always transfer the hard one into the something we already solved, right? 17 we already solved, but 17 we didn't solve. So this one we already solved. How do you do conversion into this one? That we have to do some, say, have some adjustment or some change. See, because this is positive, that means greater or equal to 1. This is non-negative, greater or equal to 0. If I do a swap, if I find a new, with using the new polynomial y1, if I define y1 equal x1 plus 1, y2 equals x2 plus 1. Okay, y3 equals x3 plus 1. Okay, keep going until y6 equals x6 plus 1. So each of them just plus 1. What did you see? So all that means all the y1 from to y2, y6, sorry, y1 to y6, they are all greater or equal to 1. You see that?
Yes.
Yeah, see, if I, so from here, okay, I can, it's 0 equals to x1 equal to y1 minus 1, correct? Just move the 1 to the left, or each side minus 1. Do you understand this one? That means x1 equal to y1 minus 1, right?
Yes.
Then we do substitution. So we put this x1 here. This is the same. x2 equals to y2 minus 1, right? So x2 here until x6 here. So this equation change to y1 minus 1 plus y2 minus 1. Keep going until y6 minus 1 equals 12. Then I move all the minus 1 to the right hand side. That means plus 6, right, on each side. Okay, this becomes, so we don't need minus 1. We add 1 to the right. Move that to the right. So it should be plus 6, correct?
Yeah.
And I make sure each step you understand. If I say that too fast, you let me know. I slow down. Is that correct? Okay. Now we have a new question, right? The new question is, so this one, 12 plus 6 is 18. Yeah, that's the easy one. Okay, that's 18. I read 18. So the new question is same as 17. How many positive integer solutions are there to the equation y1 plus y2 until y6 equal to 18? So I change the question. into 18. That's the only difference. Right? So this question 16 transfer into 17. 17 we already solved. Do you remember? So 17, so that's a new question, right? So that means there are 18 balls. You understand 17, right? Yeah, there are 18 balls. We have to put in how many bars? 5 bars to separate it into 6 groups, right? We already solved that before. So how many gaps are here? There are 18 minus 1. There are 17 gaps, correct? 17 gaps. 18 balls, 17 gaps. Any? Do you remember? Or you want me to write down all the 18 on the board? Okay. No worry. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right? So now the question is how many gaps are there? How many gaps are there?
19. Oh wait, 7.
Yes, one less. Okay, if we don't have cannot put the bars here, right? If you put bars here, the number should be 0. We cannot be 0. It must be more than or equal to 1, at least 1, right? So the gaps is 17. You are right. Okay, you just do the question 17 again, right? Yeah. So there are 17 gaps. Then next step, I put a bar, 5 bars in the 17 gaps. That means we have to 5 bars, right? All the bars must be separate, right? Because the 2 bars cannot put together. You put together, between them should be 0. But all the y is at least 1. So you cannot put together, right? So all are separate. So how many different combinations are there? We just do 17 questions, 17 again, right? Yeah. So that's choose 5 gaps from the 17. Annie, did you get it?
Yes.
Yes. We do this question again. You remember? There are 17 gaps, but we only need 5 gaps among them, from them, right? How many different combinations? Of course, use this one, right? Choose 5 from 17. How many different combinations? That is, yeah, Annie, do you remember? Yeah. So this is for solution for this question, right? But we already said before, this question is exactly same as the question 16. They are exactly same. Do you remember? So for the question 16, this is still the answer. They are equal, right? Equal answer. Yeah, I just do the transforming, right? Also translation from one question to another question. But all the questions are equal, are same questions. The answer, the number of the answer, right? The answer is how many combinations? They are exactly same. So done, finish. Do you see that? So this number is exactly the same as previous method. Method 2, still same answer. This number, right? Do you remember? For method, yeah, method 2 of question 16, same number. So I show you 3 different numbers, 3 different solutions, right? Yeah, now do you understand? Yeah, I just do some review or revision. Yeah, or you still have something not clear. Yeah, we have 6 minutes here. I can explain to you. Yes, and yeah, I want to, yeah, smile. Okay, yeah, these 2 questions are very, very hard. Yeah, at the beginning. Oh, yeah. Smile or angry or something I said, huh? The 2 emotions combined together, right? 2 emotions combined together. Yes. Yes. If you understand these 2 questions here, later in your future, you will be very happy. Yes. Right. Yes. I'll not be easy. Yes. Okay. Yeah. This is hard. Yeah. So it cost me say 1 class here to explain to you yet in details, in very, very details. But I have to, yes, because this is combinations here, hard questions here. All right? Yes.